Hello everyone, sorry about that. Welcome to the webinar. My name is Charlotte and I will be monitoring the chat and helping if you have any technical issues throughout. Today I'll be focusing on data quality and 1Integrate. Your host for today will be Charlie Gwicklin and I'll hand over to him shortly. Before we begin, I'd like to go over a few housekeeping items. You've all been placed on mute, however, we welcome your comments and questions by typing these into the question panel. We'll address these at the end of today's webinar in the Q&A session. If we don't get a chance to answer your question, don't worry, we will follow up with you afterwards. Finally, today's webinar is being recorded and we will share the link with you after the webinar via email. Okay, over to you, Charlie.
Thank you, Charlotte, and welcome everybody. Today I'm going to be talking about how to optimize your data quality with 1Integrate. So to start with, we'll take a look at the now infamous Dharma wheel, which talks about it puts data quality in the context of data governance and all the other kind of subjects and topics that wrap around data governance, data quality being that part of the wheel that we are focusing on here today. And just to mention as well, before we get into this one, that over the last couple of months we have been delivering a series of webinars focused on data governance. So if you're interested, you can find those on our webpage, onespatial.com, where we discussed the theory of data governance. Then there was a second webinar looking at how to put that into practice. And then we recently presented one which is around how 1Integrate can help with your data management and data governance. So we'll start by defining what we mean by data quality. Data quality is ensuring that your data is fit for its intended use, that it's fit for purpose. You'll probably find I say that quite a lot throughout the webinar. It's about ensuring your data is fit for its purpose. So we know that no data is perfect. And certainly when we talk about spatial data, it's never going to be a perfect reflection of the real world. So we need to decide what level of quality is acceptable kind of within our context and for our particular intended use. So this will mean that we need to define the set of kind of quality rules by which we want our data to conform. And in order to achieve that, we do up front, we need to be clear about what we mean by quality data. What does fit for purpose mean in our specific context? That may mean very different things to different organizations and different teams, but we really need to focus in on what matters most for our intended purpose and what is it that we want to measure and therefore quantify and qualify if our data is or isn't quality. So it's really important because good quality data is required for making confident and trusted decisions. So organizations these days are making more and more data informed or even data driven decision making. So it's really important that we have good kind of solid foundations of our data. The really good grounding is going to mean that our insights and the knowledge that we glean from that data is, ultimately more valuable. So we can see from the data, information and knowledge wisdom pyramid on the right hand side that the value increases as we move up that chain. So we need the raw data at the base, at the foundation of that pyramid, to be really solid and of a good enough quality. That's really important because we need to be able to trust in that data from which we are gleaning insights and making decisions. Trust is a really kind of key component to data quality, and obviously having data quality, having evidence to prove the quality of our data breeds that trust for the rest of our organization or our customers to be confident in the decisions that we're making. And these are just some of the benefits that having good quality data will bring to your organization. So the really obvious one at the top there is that we will be able to make improved decisions. We will have much more confidence in the insights that we're taking from our data. It also means that we will reduce risk. So again, all around confidence and knowing that what we're saying and doing with our data is indeed correct and accurate. It can also help us reduce costs, and there are various reasons why that can occur, and that can be just simply because we're not having to kind of constantly firefight and battle and fix our data at the point of use. Lots of time can be wasted in doing that. And I was a cartographer in a former life, and spent many an hour, kind of wasted many an hour, in all honesty, cleaning the data up before I could kind of create the map that I needed, its intended use. It would have been much better if I could be confident in the quality of that data before I started using it. And hand in hand with that is kind of increased revenues, but also, really importantly, enhanced reputation. That can come through an increased kind of customer experience and improved customer satisfaction. And also, which is often very important to organizations these days, is we conform to and comply with kind of legal and regulatory compliance. We're probably all familiar, anybody working with data, familiar with things like GDPR. There are many other, either company-wide or even industry-wide kind of standards and specifications that we must comply with when we're handling data and managing our data. Lots of security concerns, especially around the use of personal data. So having a good level of data quality means that we're going to be compliant. So on the flip side of that, we'll just discuss what the pitfalls are if we don't ensure we have good quality data and we end up utilizing poor quality data. We're going to end up with inaccurate decision making. We may not know that at the time that we're making the decision, so that will lead to kind of cost and risk later down the line. We're going to end up with ultimately poor insights from our analysis. And if we have dashboards displaying and presenting data to various stakeholders, we may be doing that inaccurately or incompletely. We'll lose trust and we'll lose credibility, again, with our stakeholders or indeed with our customers. And we will, of course, have decreased kind of efficiency and productivity. As I say, we'll be spending too much time fixing issues as they arise, and making up for those kind of poor decisions in the first place, rather than having a good solid foundation on which to make these decisions in the very first place. We will have increased costs that are incurred from those types of activities, and we may not comply, and we may leave ourselves open to some legal challenges and legal risks. And yeah, potentially we could lead to a negative customer experience, which is only going to damage the reputation further. Often when we talk about data quality, we refer to these 6 data dimensions. Again, these come from DAMA. So we've got completeness, ensuring that each of our records within our data set is fully complete. And that, again, we may have mandatory and optional fields within our data. It's really to ensure that all of those mandatory fields are filled in. Uniqueness, to ensure that we don't have duplicate records within our data sets. A good kind of case study for this is kind of address data. If we're holding addresses for our customers, when we're mailing out to them or delivering to them, we want to ensure that we don't have duplicate records, because that can lead to all sorts of problems down the road. It's important that our data is timely as well, and by this we actually mean a couple of things here. So one is that our data is updated in a timely manner, and our specifications may kind of have some things in there around, for example, records need to be updated every year or every 6 months or every month. So there's that side of timeliness, and there's also the element of the data is available and ready to be used by the people who need to use it in a timely manner. So it's the right people at the right time. And then we have validity. So we talked about completeness. We want to make sure that all of our data especially in those kind of mandatory fields, is complete. But the other side to that as well is to make sure that data is actually valid and correct in the first place. So it's no good having a value in a field if that value is the incorrect value. So we need to check for the validity of those features and their attributes and metadata as well. And accuracy. So we need to ensure that obviously our data is accurate, so we're not misrepresenting whichever phenomena our data is representing. And consistent. We want our data to be consistent. This one really plays into kind of interoperability and reuse of our data. And the value of data increases greatly when it's connected with other data sets, and those types of connections would not be possible if there were inconsistencies within our data. So these are 6 really key pillars of data quality to keep in mind as we're looking at kind of what to measure and what to kind of defer data quality from. And if we talk about spatial data specifically, there are a couple of quality measures that spatial data is particularly sensitive to due to things like storing a geometry representing real-world features. And those 2 things are accuracy and completeness. So in terms of accuracy, we need to make sure that the positional accuracy of our data is correct, and that the geometric representation of the location or the feature in the real world is truly representative, and also topologically correct. So if we have a pipe network, it might be a utility company maintaining our underground assets in a kind of digital pipe network. We need to ensure that that's topologically connected, so that the end of each line connects to the next line. There's a nice connecting node in the middle. If we don't have that, then if we're running analysis across our data, then we're obviously going to, they won't be joined up, so things won't flow through, and we're going to get the wrong insights back from that analysis. Temporal, so how a feature changes over time. So just a really kind of basic example of that is if you're maintaining a set of building data, then if a house is changed, if added an extension, or the garden is, the shape of the garden has changed, maybe the fence moves out, we need to make sure that that is represented and updated again in a timely manner. Things like coastal erosion as well, really good example of that. We need to make sure that when we're using this data for analysis, that we're using the most accurate and up-to-date information. And thematic, so things like the attribution that describes the particular features within our data set, we need to make sure that's correct. And another example of that might be you have a river network data set, just making sure that the classifications or the types or the subtypes, however they're referred to within the data, that they are correct for the feature they're representing. That can be the difference between describing a river or a canal, which again, for when you're trying to do insight analysis and gain insights from that data, these things become very important. And then we move on to the completeness of the data. We want to make sure that no data is missing. Does that pipe that we've talked about have an appropriate connection with the next length of pipe in the network? And also the detail, so is the required level of feature detail captured, and again, is that suitable for the use in which we're going to put it? So this is a kind of visual representation of a couple of spatial errors, and these are a couple of examples that would be very easy to miss if we were just looking at the data with the human eye. And this is why automation becomes so important to ensuring and maintaining data quality. So on the left-hand side, we talked about pipes in a utility network. This is a good example of that. If we're panning and zooming around a map and we're quite zoomed out, as the kind of diagram on the left-hand shows, it may appear that that network is fully connected. But if we were to zoom in on that particular junction, we can soon see that actually those 3 lines don't join up, and none of them actually connect to the junction, the connecting node in the middle. And then on the right-hand side, again, potentially this would not be easy to spot with the human eye, especially if the right kind of cartographic styling wasn't applied to the data. What we have here is a subtype 10 on the pipe connecting into a node with subtype of 20, when we may have a rule within our data set whereby the subtypes must line up where they connect. Again, just an example of something that would actually be very easy to miss if we didn't automate our data quality checks. So ultimately, we want our data to be of a good quality. We want our data to be fit for purpose. And the ultimate goal of that, the reason we want to aspire for that, is because we want our data to be useful, we want it to be usable, and ultimately we want it to be used. So we know that data unlocks lots of value for our business. The value of that data is only going to increase the more that we connect it and join it up with other data sets. And then really, the value of that data is only realized if it's used. But as I say, the data quality underpins all of these things. Without it, we wouldn't be able to trust our analysis, and therefore we wouldn't be able to glean the full potential and all the value that's inherent within that data. So at 1Spatial, we kind of help people maintain and ensure their data quality to make sure they can trust their decision making. We do this by combining our expertise and our technology, and that's why I'm going to move on to talk about 1Integrate and how 1Integrate can help ensure that your data is indeed fit for purpose, that it's compliant and is of a consistent quality. So what is 1Integrate? 1Integrate is a no-code rules engine, and it helps you automatically check, correct, and/or transform your data. And here's a few of the key capabilities of 1Integrate and how we enable those things. So it's a no-code rules engine, so it's got a nice web user interface. You don't need to be a developer or a programmer in order to be able to use 1Integrate and write the rules. It helps you measure the quality of your data, and then if you find there are features within your data that don't conform to your data quality measures, then we can also use it to fix and enhance the data as well. And we can do that all in an automated way. It's all about knowledge management. So you may find that you have lots of business rules, lots of technical rules, data specifications. Lots of this information will exist within your organization, but it may only exist in silos. It may only exist in people's heads. It may only exist in notepads and folders that are put away in dusty shelves. So this is about encoding all of that knowledge and putting it into 1Integrate, where it can be easily stored, managed, shared, reused, edited, and used over time. That's really quite powerful. We enable automation through the REST API, and that enables you to kind of integrate into your other systems, and also trigger and run the data processing as and when you need it to run. There are a whole bunch of native data connectors, so you can bring in data from lots of different sources, be those file-based, database, or indeed increasingly web services. It's scalable. It's a server-based application. It can be deployed anywhere. We can deploy on-premise. We can deploy on the cloud. It can be provided as a SaaS solution or indeed a hybrid, whatever kind of suits your kind of architecture. 1Integrate will work with spatial data. That can be 2D or indeed fully 3D data, but also non-spatial data as well. And what's really powerful is when we start to connect various data sources together and combine them and connect them and join them up. So we can work with, we can cross-reference lots of different data sources, integrate them together, and ultimately kind of combine that information into more useful knowledge and insights. And as I say, it's all accessed via a web browser, nice intuitive web user interface, which we will take a look at in just a moment. So we're really pleased actually that we've just recently released a brand new version of 1Integrate, and we put a huge focus on user experience. So it is now more intuitive than ever to use. It's really going to help users increase productivity. It's got a really nice kind of modern design. It's nice and easy to use, and it really is, a huge leap forward for the product. So I'm really pleased and proud to be able to show you that today, and I will be doing a demo in just a moment. So this is what the interface looks like. And first of all, before getting into the demo, I just wanted to discuss a little bit about how we approach data quality, and we take a rules-based approach within 1Integrate. So as I mentioned previously, you encode your rules so that they can then be automated, and this allows you to assess the quality of your data on a regular basis, and you can do that in a consistent way, which really does help, not only improve the data, but kind of allows you to identify and monitor any trends over time as well. So the rules within 1Integrate sort of form the basis of your data quality management. That allows you to audit, measure, improve. As I say, we can do data improvements and fix-ups in an automated way, or if they are done manually, we can just report on those really clearly to the teams that need to go and make those manual edits. So as I mentioned, like a rule is really easy to kind of manage and store within 1Integrate. They can be backed up easily. They can be shared and reused across teams and departments and projects. And they're really easy to configure and adapt within the interface. So it means that everything we do within 1Integrate is repeatable, and it's traceable, and it's shareable. So we may start a new project that has a lot of similarities to our previous project, and we might be able to reuse, a whole bunch of those rules, and maybe make slight tweaks and edits to them, but it means we're not going to have to kind of start the project again from scratch. So this is the structure of a rule within 1Integrate. So the example here, we might have this rule kind of noted down or documented in a spreadsheet or a Word document, and that may say something like, I want to check that all the buildings in my data set have a function code of 1810. So we convert that into the logic that we need to put within the 1Integrate rule. So buildings should have an F code, and that's the attribute that's stored on the data set of 1810. And then we write that logic out, and in the bottom right hand side here, this is what that looks like within the 1Integrate interface. So we have our root node for the buildings. So we're saying we want to do something with our building features, and the thing we want to do is check that the building feature code equals 1810. So this is just a very basic example of what that logic ends up looking like within 1Integrate. And the rules are developed so that they resolve as true, which means that any feature that returns false is reported to the user as a non-conformance. So for example, if we had 100 features in our building data set, 99 of them had the code 1810, but one had, let's say, 1910, you would receive one non-conformance, and it would pinpoint you very accurately which of those features did not conform to your data quality rule. So if we put that into practice and look at another example, this is again just a simple geometric data example here. I want to check that no buildings overlap the curb lines in my data set. So this is what that rule would look like within 1Integrate. We have a rule for our curb lines. We want to make sure that 0 buildings exist for which the building geometry overlaps the curb line geometry. So just to bring that to life with these images at the bottom here, on the right hand side, we can see that this curb line has 2 buildings which overlap that curb line feature. Therefore, this particular curb line feature would be reported to the user as a non-conformance, whereby our curb line on the left hand side although we have one that is wholly within and one that is kind of near it, neither of those buildings actually overlap the geometry of our curb line. Therefore, this would pass the rule and not be reported as a non-conformance. So I'm just going to go at this point into 1Integrate itself and just discuss what the interface looks like and how we might build up that rule that we've just taken a look at. So we can see here that I have a data store. I've already loaded in the data that I'm interested in. This data is coming from an Esri shapefile, and we have information about buildings and curb lines, fire stations, and so on. These are all the classes within our data. If I just expand the building class, we will see then that these are all the attributes represented on that data set. And I'm just going to move over to start developing a new rule like the one that we just discussed. So to do that, I already have a folder set up ready, and I'm going to add a new rule to this folder. I'm going to call it curb line overlaps and create my new rule. And you'll see here that I have a kind of canvas to start developing my rule from. The first thing I'm going to do is bring in my data store context. So this means that I'm bringing in the schema from my data set so that I can write my rule against the exact schema of my data. So my rule for all objects, I'm going to change that for rule for curb line objects. And then I'm guided through the interface to the next element that I need to add to my rule. So I'm just going to click plus on the predicate here, and I'm going to choose existence in this instance. And I know that we want to make sure that there are exactly 0 building objects. And next thing we're going to do, and in fact, I'm just going to collapse the left-hand menu so I have a bit more screen real estate to build my rule. I'm going to add a check. It's called a check that. And this is where I want to say, I want to check that my building geometries don't overlap the, so I'm going to choose building geometry in this one. And then my relationship is, in this case, a spatial relationship. But you can see here that we have a whole list of scalar and spatial relationships that we can choose from. In this particular instance, we want to say where 0 buildings overlap with our curb line. So I want to choose the curb line geometry attribute in this case. And there I have my rule all created. If I wanted to, I can start to add comments to my rule. So if they get particularly long and complex, I may want to leave some notes or descriptions or reminders for my colleagues. And this is just one of the tools within 1Integrate that make it a nice tool for kind of collaborative working as well. So now that I've created my rule, what I want to do next is add that to a session. So I've already set up a session previously, and a session within 1Integrate is where all the data processing happens. So I set up my data stores, set up my rules and my actions, and then I bring them all together in a session, which we can play, stop, pause, rewind, and that's where the data processing happens. So I'm already loading in my data that we looked at. So this is the Philly data that has the buildings and the curb lines and all of those other classes in there. And I'm now going to add my new rule to this session. So my curb line overlaps rule, I'll just double click on that so we have one selected rule. And I will load this into my session. Just going to drag it up above the pause, and we have a pause at the end of our session here so that we can stop at that point and view the results. If I just hit save and run this rule, we'll see that that should run nice and quickly through the data. We're processing around 15,000 geospatial features. And if we take a look at the summary for the data that we've opened, we can see that 1,811 of those features were from the curb line class. I can then see that all of those curb line features were passed into my rule, and it had 95.8% conformance. So there are 76 features within my curb line data set that are overlapped by a building. So there's a couple of ways we can look at the results for this. We can look at that in a tabular format. So we can see all of those features described and it mentions that they are non-conformant to this particular rule. We can also download those results in JSON format if we want to. There are many options as well within 1Integrate for exporting the results of that rule. We can export them into a CSV, back into a database, or indeed we can export those as a geospatial file, which would be really handy if we wanted to go into our another GIS and load those non-conformance points on top of our data. And that's a really nice way for us to identify, discover, and fix up any of these issues that we discover. Another thing we can do within 1Integrate is go ahead and look at the map. So this is where we're looking at the results in a visual way, bearing in mind that this is spatial data. So I've got my whole list of classes here. You can see I've previously already kind of turned on and off the layers that I'm interested in. So we're just focusing on our curb line data and our building data. And if I come up to the reports, what we can then start to do is cycle through each of those non-conforming objects one at a time. And as I do so, you'll see that the map pans to the feature. You'll see that we have these nice little pins on the map that would tell me exactly where the features overlap, and we can see that and just kind of validate that visually. But also, as I flick through the issues, we also get the attribute information for that given feature as well. So it's really nice and easy to find where a particular feature within our data set does not conform to our data quality rule. So that's just one example. Hopefully you can think of examples within your own organizations or in your own data sets where you might be able to write a kind of similar rule, whether that's spatial or non-spatial, or whether that's a geometric rule or an attribute rule. They all work in the same way within 1Integrate. I'm just going to hop back to the presentation now. So these are some additional rule examples. We already talked about those 6 dimensions of data quality. So I've just listed out one example rule for each of those dimensions. So for accuracy, we may say all address points in our data set must sit within a building polygon. And hopefully you can see now how that could then be transferred and encoded into a 1Integrate rule. In terms of completeness, we may want every feature to have a value in the name attribute, and we can ensure that there are no null values and that all of those fields are indeed populated. Uniqueness, we may want to ensure that there are no duplicated records in our customer database, so we can remove those and deduplicate, combine the salient information from both if that's what we need to do. In terms of consistency, we may want all geometries in our network data to be a single part geometry, so we can ensure that we're not having any multi-part geometries creep in. That can often cause issues later down the line when we're running our analysis. Timeliness, we may want all of our records to be updated within the last 3 years, so we can check the timestamp attribute within our data and flag any that have not been updated within that 3-year period. And in terms of validity, an example of that might be that we want all geometries in our database to conform to the OGC simple geometry specification. And in the case of that, we have a built-in function within 1Integrate to enable that really quickly and easily. And as I mentioned, as I was showing the demo there, it's a really great tool to enable collaborative working. This is obviously increasingly important as we have kind of distributed workforces and people are kind of working from home more and more these days. It's a web-based tool that everybody can access to, everybody can access, and you're all looking at the same data at the same time. So we've got the web-based no-code user interface, we have really thorough online documentation, and we also have training for the product. We have folder and file structure. That's a very familiar and common way to kind of store and manage our rules and our actions. I gave an example of adding inline comments. We can do that within our rules, within our actions. We can add comments within our sessions as well. We have backup and restore capabilities. So I mentioned it's really easy to kind of share our rules and actions across teams, across projects, and we can do that by backing up and restoring into another instance of 1Integrate, or indeed we also have a synchronization tool so that you can handle all of your rules and actions in a version controlled manner. So as an example of that might be that you're syncing into a GitHub repository and the whole team can ensure that you're working on the latest and greatest of everything. We also have access groups, which is just a way for administrators to control who gets access to which entities within the product. So you may have multiple project teams working within the same instance of 1Integrate, and you can make sure that project A can't go and edit project B's rules, and so on and so forth. And my point at the bottom is slightly light-hearted, but I'm sure we're all familiar with this one, whereby we're all editing data locally. We'll download a local version of a spreadsheet, make our own edits, and then you realize, oh dear, I didn't quite make the edits correctly. So you end up with the crazy long file names like _v3 _final. The next one will be _final2, and so on and so forth. So as I say, everybody collaborating in the one tool means that we don't have to make these local edits, and we're always working from the source of truth. So 1Integrate is part of the one spatial platform that can enable and ensure and maintain data quality. We can share consistent rules. So as I've shown, we create the rules within 1Integrate. These can be shared across the platform. And a platform consists of a mobile offering called 1Capture, which is about people out in the field capturing data at the point, at point of capture. 1Capture enables you to run those rules, those data quality rules, to make sure that you're getting the data right at the time of capture. 1Data Gateway is all about our supply chain management. So if we're getting data supplied from various different companies or different suppliers, then we can ensure that they are supplying their data through a really easy to use drag and drop interface, but that we're running the same rules at the point of submission, so that all the data coming into our kind of data ecosystem and our system, in our kind of internal systems, is all going to align with our data quality measures. So just a quick slide to show who's utilizing 1Integrate currently to kind of realize the value from their data. We have national mapping agencies such as Ordnance Survey, a huge organization that are collecting and supplying thousands, millions of data records on a daily basis. Really important to them that they ensure the quality of that data so that the customers using it can trust it and know that decisions they're making based on that data is accurate and correct. We've got Google environment agencies. There's lots of companies across government, across transport sectors, and across the utility sectors, all utilizing 1Integrate and the one spatial platform to ensure that their data is maintained at a quality level. So we're probably all on a different point of the journey to achieve good quality data, and that might be data that we're using internally. It might be data that we're sharing with our customers or supplying to our customers. If you're at the kind of start of this journey, then a good place to start will be to sort of ask yourself some of these questions and get answers to some of these questions. So how much data does your organization hold currently? Do you know what the contents of that data are? And do you know what the format of the data is as well? Do you know where it's all stored? Is there a single source of truth? Are there specific roles within the organization that are kind of managing that data, or should there be data owners that should take ownership of that data? Do you regularly assess the completeness and the accuracy and the currency, thinking back to those kind of 6 dimensions of data quality? Are you regularly making sure that those things are maintained? Have you identified relationships that exist between data sets? So it may be that one data set relies on the information from another, or you know, like we mentioned right at the start, we get more value from data once we start to connect it together. So are we missing a trick by not putting relationships within our data? Do you know what data quality looks like for your intended purpose? And are you using automated rules to spot and fix those issues? You know, automation is really important for saving lots of time, ultimately saving money, saving, you know, our reputation and all those kind of things that we spoke about at the start. If you're interested in what you've heard on the webinar today, then you can trial 1Integrate for free for a month. So you can find more information on the product page. You go to onespatial.com/1Integrate. There's a really easy form to fill in if you're interested in getting your hands on 1Integrate for a trial. Kind of no credit card needed in order to get started, no additional software. We will deliver it as a SaaS product. There's no need for kind of IT support or installations, and we will provide you our online training modules to help your team get started. So that was it for me today, just to say thank you very much. Lots of our contact details on the screen now. We have a presence right across the world, so wherever you are, whatever region you're in, please do get in touch for further information. And yeah, just to say thank you, and I'll maybe ask Charlotte now if we've had any questions come through as I've been talking.
Thanks, Charlie, that was great. Yeah, we've had a couple of questions. So the first one, actually, I think I can answer this, which is, will the session be recorded? It will, and as I mentioned at the start, they probably missed this, but I will send out the recording after the webinar is finished. So probably a couple more 1Integrate specific questions. Well, the first one's on data quality. So they've asked, what formats are the data quality reports available in?
Okay, yeah, really good question. So I showed, as I gave the demo, a couple of examples of where you can look at the kind of reports that come out of 1Integrate. So there are various options. You have the map within the product itself. You can download the report as a JSON file. That could potentially be, that could drive, you know, some BI reporting software. But actually, the user is in control, and it's highly configurable. So you can select any of the data stores that are native to 1Integrate. For an example, you could export your data quality reports in a CSV, could be sent back to a Postgres database, or indeed, it could be a geo package or a shapefile in the case of spatial data, which means it's really easy to kind of overlay that spatial report onto your existing data. So yeah, I think the answer to that is kind of whatever you kind of need it to be to make that useful to your users, I guess.
Perfect. So the next question we've got in is, can I integrate and cross-reference data from multiple sources?
Yeah, absolutely. And that's something that's kind of really core to the 1Integrate product. Not only is it in the product name, but absolutely the ability to bring in information, data from various, you know, it could be disparate databases, could be that you might be merging data from a database with data from a file. And yes, absolutely, through the rules and actions. I mean, I guess as I showed in the demo, actually, where we're combining data from curb lines to data with buildings, we can absolutely integrate those from various different sources.
Brilliant. Okay, and the last question I have is about training. I know you mentioned it in the trial that there's online training, but they've asked, is there any training available for 1Integrate?
Yeah, there is indeed, and yeah, anybody that's interested in a trial, as I say, you'll get your cloud-based instance of 1Integrate for 30 days, and we will also give you access to our online training material for that as well. So we have online self-paced training modules. We have a kind of beginner and a more advanced, and that, as I say, that can be taken online, or if it's preferred, we can give kind of instructor-led training online, or indeed on premise if that's what's required.
Brilliant. Well, that's it for the questions, unless anyone has any others. I want to quickly get in. So no, I think that's it. Thank you, Charlie. Just to let everyone know that when the webinar's finished, there will be just a couple of questions pop up, which I'd really appreciate if you answer. It will take less than a minute. But thank you so much, Charlie. That was great. And I will send the recording out to everyone after.
Thank you. Thank you, everybody.
Thanks.
Bye-bye.